Today we are looking at factoring perfect square trinomials, and this is a slightly special case of just regular factoring by grouping. In truth, the process we're going to use is going to be exactly the same, but at the very end, we're going to come up with a little bit of a strange point that we need to address. So the example we're going to use is x squared minus 6x plus 9. And once again, we're going to start by looking at our a, b, and c as we have in the various other problems we've done. So our a in this problem, well, that's the implied 1 attached to the x squared. So it's just a equals 1. B is equal to -6, and c is equal to 9. And on this particular one, I chose to do this because it gives us an opportunity to practice the shortcut that we learned about in the last video. So we should be able to figure this one out in fewer steps than the conventional method we initially learned. So what we can do here is we can take this a, b, and c, and normally we would use a times c, but a times c just equals 9, which is c. So for this one, with our c is equal to 9, we need to multiply to 9. And for our b is equal to -6, we need to add to -6. So when we think about 9, we want to think about our positive and negative factors of 9. And all the numbers that divide 9 are only 1, 3, and 9. 1 times 9 is 9, and 3 times 3 is 9. Now, as you might be able to imagine, because this is factoring perfect square trinomials, we're going to utilize the fact that 9 is a perfect square here. And if we look at this, we would say, okay, we have 3 and 3, but then you'd say, hold it. I'm adding up to -6. So this actually needs to be a -3 times a -3. So these positive numbers, the square root of them is both positive and -3. And because in this particular example, we needed to add up to that -6, we need to add up -3 plus -3, which is, of course, -6. So this all checks out. So we know that these are the numbers we are looking for. And because we have an a value of 1, we get to skip all of the work we did in the previous section and simply write our answers out, which is x minus 3 times x minus 3. So this is the result you're going to get when you factor perfect square trinomials. Your answer will end up looking like one factor times itself. And what I want to emphasize here and mention is that we can rewrite this as x minus 3 squared. Remember when we had like x times x, that was x squared, or 3 times 3, even though that equals 9, you could write it as being 3 squared. We can actually do the same thing here. So x minus 3 times x minus 3, that's the entire thing squared, because obviously, if we rewrite this as x minus 3 times itself, that's x minus 3 times x minus 3. And if you need to check your work by distributing, you can go ahead and do that too, and you will find that these two are the same in case you still need a little bit more convincing about how this shortcut actually works. The only other thing I want to mention is that sometimes perfect square trinomials are not actually immediately obvious. And this is a reminder to factor using the greatest common factor before engaging in factoring by grouping. So with the greatest common factor, take this initial problem, for example. If it had been written as 2x squared minus 12x plus 18, it would not perhaps have struck you as being relatively obvious at the beginning that this is actually a perfect square, because there isn't even a perfect square available. We don't have the 9 that we would be looking for. But this is why we need to do our factoring. So if we factor out the greatest common factor, all these numbers are even and have a 2. So that means we can pull a 2 out of a 2 to just give us a 1, or simply an x squared. Then we can pull a 2 out of a -12, which gives us -6x. And we can pull a 2 out of an 18 to give us a 9. And you could, of course, validate that these two statements are equal by distributing the 2 through. From here, we would proceed as we did before. We'd still end up with this thing here, only with a 2 out in front as well. So that's just a word of caution when you are looking at these problems, to make sure to always factor out the greatest common factor. Otherwise, it'll make your work when you're going through and factoring them by grouping much more difficult.